Okay, 4.3, day 3, we're doing synthetic division today. This is an alternate method for dividing polynomials, but it only works when you're dividing something of the form of x minus something or x plus something. Meaning like this is x minus 2, this will work with synthetic, this is x plus 1, this will work with synthetic. It will not work if you're dividing by something like 2x plus something. Okay, when you do synthetic division, if the factor is x minus k, we use the value x equals k in our synthetic division. Okay, now the first one, we're gonna try it out so you can see how it works. Many people prefer this when it's available, but eventually it'll be up to you to do what you think in each situation. Okay, so I'm gonna do synthetic on this one. As 3x cubed minus 2x squared minus 13x plus 14. Because this is of the form x minus 2, I can do synthetic. In order to do it, I need to figure out what x equals 2. If I were to make this equal to 0, I would plus 2, so I would get x equals 2. Okay, now when I set up the synthetic, I want to use the 2 that x equals 2. So this is what it's going to look like. It's going to look like this. Wait and see the whole thing before you write it down. It goes like this. This is 2 rows here. Okay, now on the top row here, I put the coefficients of this polynomial in order. If something's missing, I put a 0. So 3x to the third, negative 2x squared, negative 13x, and then positive 14. Okay, now there's going to be a remainder. I like to put a dash line here to help remind me when I get to the remainder. Okay, this is the setup. Now let's try it for real. Okay, now the first number here, the 3, it just goes straight down to the bottom row. Okay, now I do this number times this number and I put it here. So 2 times 3, 6. Okay, now I add this column up. Negative 2 plus 6 is 4. Okay, now I'm going to repeat. I'm going to do this times this, and I'm going to put it here. So 2 times 4 is 8. Then I add down. Negative 13 plus 8 is negative 5. Okay, now I'm going to repeat again. This times this goes here. So 2 times negative 5 is negative 10. Then I add down. 14 minus 10 is 4. Okay, I told you I like to use the dash line to indicate my remainder. So this is my remainder here. Okay, now this 3, 4, negative 5, that represents the coefficients of my polynomial in my solution. So this is the constant, and then I'm going to go up. This must be x, and this must be x squared. So then my answer is 3x squared positive 4x minus 5. My remainder is 4 divided by, what was I dividing by? X minus 2. So I need to put it back into the polynomial form. Okay, and then this is my answer. If I do long division, I will get the exact same answer. Okay, now that you've seen it, let's go ahead and try the next one. Okay, I'm doing this divided by x plus 1 because this is of the form x plus or minus something. I can do synthetic. First, I need to figure out what x equals to for this to be 0. So if I minus the 1, I get x equals negative 1. So when I set it up, negative 1 is the number that goes on the outside. Okay, I'm going to do this weird upside down box. And then along the top row, I put the coefficients in order, and I put a 0 if I'm missing a term. So 5x cubed, negative 2x squared, negative 4x, positive 3. I like to put the dash line. It reminds me when I get to the remainder. Okay, now let's start with the first thing. First thing is this one comes down. So 5 comes straight. Okay, now I'm going to start the multiplication where I do this times this, and it goes here. Negative 1 times 5, negative 5. And then add down. Negative 2 plus negative 5 is negative 7. Okay, now I'm going to multiply again. This times this is this. Negative 1 times negative 7, positive 7. Add down. Negative 4 plus 7 is 3. Okay, this times this is this. Negative 1 times 3 is 3, negative 3. Okay, add down. 3 minus 3 is 0. So the remainder is 0. Okay, this represents the coefficients of my polynomial. I'm going to go backwards. This is my constant, my x, and my x squared. So this must be 5x squared minus 7x plus 3. Since there's no remainder, I'm not gonna put any mixed fraction. Okay, we're gonna try C. Just be careful, C is missing a term. Okay, and synthetic works here because it's x plus 3, but remember if it's x plus 3, what is x equal to? -3. Okay, set up my little weird box. 2x cubed, there's 0x squareds, -1x, -7, and I'm gonna mark off where my remainder is, and I'm gonna bring my 2 straight down. Yeah, you don't have to put the arrow, but some people like to remind themselves. Okay, multiply, -6. Add down, -6. Okay, multiply, put it here, -3 times -6, positive 18. Add down, -1 plus 18, 17. Okay, -3 times 17, what is that, -51? Okay, add down, -58. Okay, there's my remainder. These are the coefficients of my polynomial, so constant x squared. So x squared, 6x, 17, my remainder is -58, and I was dividing by x plus 3. Okay, synthetic division can be used to evaluate a polynomial function. To evaluate f of k, you use synthetic division by k. F of k is going to equal to the remainder. Okay, so I want to do f of -1. I could just plug -1 in here, here, and here, and I will get the answer, but I could also do synthetic, so we're going to try to do synthetic here. So I want to plug in -1. -1. I'm going to try synthetic here. Okay, I'm plugging it into this function. So 5x cubed, -1x squared, 3x, 9. The remainder is going to be my answer, so let me make sure to mark that off. The 5 is going to come straight down. -1 times 5 is -5. If I add down -1 and -5, -6. -1 times -6, positive 6. Okay, add down, 3 plus 6 is 9. Okay, -1 times 9 is -9. 9 minus 9 is 0. Okay, now the remainder is the answer. So this is actually what f of -1 is. So f of -1 is equal to 0. Now if I used a calculator, I would get the same answer. Let's just look at this. Is that actually correct? 5 times -1 is -5. -1 squared is what? -5 minus 1 is -6. Minus 9 plus 9, I would have gotten 0. Okay. Sometimes this is actually faster than actually plugging the -1 in. Okay, let's try it with 2. I think that 2 really is faster using synthetic than plugging it in by hand. So let me do 2. Okay, I'm plugging into 5x cubed minus 1x squared plus 3x plus 9. Okay, let me bring down the 5. 2 times 5 is 10. -1 plus 10 is 9. 2 times 9 is 18. 3 plus 18 is 21. 2 times 21 is 42. What's 42 plus 9? 51. Okay, my remainder is going to tell me what the answer is when I plugged in 2. So it's my remainder, but it's also what f of 2 equals. So f of 2 is going to equal to 51. Okay, and if I plug 2 into this function, I should get this answer. But sometimes synthetic is actually easier or faster than plugging it in and worrying about order of operations and everything else. Okay, so let's use synthetic division again, and this time it's going to help us get the points on our graph that are missing. Okay, and this is also going to remind us of all the other stuff we did before. Okay, let's go ahead and go through these normal steps. Okay, here's my polynomial. I'm going to plot the zeros at 4, 2, and -3. So where is it? 4, 1 to 2, and then what's the other one? -3, -1, -2, -3. Okay, I should label them, but since I'm doing it by scale, I will do it that way. Okay, let's consider our end behavior. Okay, is this even or odd? This is cubed, so it's odd. So it's going to be one side up, one side down. The coefficient is negative. Okay, so it's odd and it's negative. So it's like a negative slope. So it's going to go down on the right and up on the left. So on the far right, it's gonna go down, it's gonna go up. Okay, now pick an x value between each of the zeros. Use synthetic to evaluate the function at these points. Okay, so I wanna use synthetic to figure out the values. And see, if I go between, what is this, 2 and 4, let's plug in 3. So I want f of 3. I'm gonna use synthetic. So let me do 3. Let me set it up. Negative 2x cubed, 6x squared, 20x, negative 48. Bring down the negative 2. Okay, 3 times negative 2 is negative 6, which is 0. 3 times 0 is 0. 20 plus 0 is 20. 60, what's 60 minus 48? 12? Okay. So at f of 3, I got 12. So on my graph, I'm going to go to 1, 2, 3. 3, 12 is somewhere up here. So it's going to go up. Okay, now let me pick a number between here and here. Now I kind of just want to plug in 0. Now the thing about 0 is I could do 0 in my head. Let's do it in our heads and then verify it. If I plug in 0, I get 0 plus 0 plus 0 minus 48. I should get negative 48. Okay, I'm going to do synthetic just to verify it, but I think it should be 0, negative 48. Bring down the negative 2. Okay, I have 2 times 0. 0, 6 plus 0 is 6. 0 times 6, 0, 20. 0 times 9 is 0, negative 48. So f of 0 is negative 48, which I already knew, but we use synthetic to check it. So it's going to go down here and then come back up. And I'm going to go ahead and label this as 0, comma, negative 48. Okay, so now you should know how to do synthetic division. And then when you're evaluating a polynomial function, there might be times when it is easier to do synthetic than to just plug it in.